Hi, I'm Helen from Microsoft Windows Protocol Test Suite team. In today's session, I will give you an introduction on our Microsoft FileServer Protocol Test Suite, and my colleague Obaro will talk about the latest updates for our recent GitHub release for Protocol Test Suite. Here's the agenda. I will first talk about the overview for FileServer Test Suite. And then I will briefly talk about Test Suite open source and cross-platform. After that, Obaro will talk about what's new for the recent GitHub release, especially on the SMB2 areas, and follow up with a demo. Here's the overview for FileServer Test Suite. So what is a Windows Protocol Test Suite? A Windows Protocol Test Suite evaluates whether a protocol implementation can meet certain interoperability requirements. At the very beginning, it is developed for our in-house testing for Microsoft Open specifications. We also use it to test and verify Windows behaviors. It can also be used to test third-party implementations. We do not cover every protocol requirement and details, and do not certify an implementation, but we hope that it can be a useful indication of interoperability. Here's the scope for FileServer Test Suite. For protocols, we cover MS-SMB2, MS-FSA, MS-SWN, MS-ISVD, MS-FSRVP, MS-SQoS, MS-DFSC, and MS-HVIS. We also cover messages like negotiate, session setup, tree connect and disconnect, create and close, IOCTL, query directory, and query info. For features, FileServer Test Suite also supports the following features like negotiate, session management, tree management, credit management, signing leasing, persistent handle, play, and app instance ID, as well as other messages. Our FileServer Test Suite supports dialect from 2.0 to 3.1. For test approach, FileServer Test Suite mainly use traditional test and model-based test. For traditional test, we mainly cover basic functionalities and scenarios. For model-based test, we've developed over 2,000 test cases generated by 13 models. We have better coverage on the parameter combination, message sequence, and the negative tests. Here is the infrastructure for FileServer Test Suite. We have the driver computer acts as the synthetic client to test against SUT. The system under test is a file server that can either be on Windows, Linux, or other platforms. The underlying traffic goes through TCP. The FileServer Test Suite is developed on top of Protocol Test Framework, which is based on Visual Studio Unit Test. The Protocol Test Framework provides functionalities like configurations, adapters, logging, and network captures. The FileServer Test Suite also includes test cases, Protocol SDK, and SUT control adapters. The SUT control adapters can be used to make configurations or set status on SUT. Here's the environment for our FileServer Test Suite. We have two types of environment. One is standard, the other is FileServer cluster. For the standard environment, we have a domain controller for our SUT and the driver computer to join the domain. For FileServer cluster environment, besides for the domain controller, we also have several roles and nodes. We have two nodes here, and we also have scale-out FS and the general FS. We have set up these two types of environment for our SMB3 IO lab. So if you are a participant for our SMB3 IO lab, feel free to contact us for these two testing environments. Now I'd like to talk about the open source and the cross-platform effort for our Windows Protocol Test Suite. In the recent releases, we have migrated from previous .NET Framework to .NET Core SDK here, which enable us to have the capability to support other platforms like Linux and Mac OS than Windows. So now all our components like Protocol Test Framework, Protocol SDK are built on top of .NET Core SDK. Therefore, our FileServer test suite, RDP test suites can now also run cross-platform. We are also developing cross-platform versions for PTM and PTM CLI. We have open-sourced our Windows Protocol test suites on GitHub since 2016. Here are the two repos we have. Besides for the file sharing protocol test suite families, we also provide other test suites on GitHub, like the security protocols, the Active Directory protocols, the remote desktop protocols, and the BYOD protocols. If you are interested, please take a look on our GitHub repos and feel free to contact us to raise issues, to send us pull requests and feature requests. We will take a look at these issues, pull requests, and feature requests from time to time on our GitHub repos. Now, I will hand over to our colleague Obaro to talk about the latest updates.
Hello everyone, I'm Obaro Ogbo from Microsoft ADC in Lagos, Nigeria. In the next few minutes, I'll be sharing some of the work we've been doing and discussing what's new in the latest version of Windows Protocol Test Suites. Then I'll walk through a demo to show how you can run these tests step by step. The latest version of the Windows Protocol Test Suites is version 4.21.5.0 and it's available for download today from GitHub. The link is on the screen and on the slides, which will be available on after the session. Some of the things we worked on for this release include the FileServer test suite, which we have migrated from .NET Core 3.1 to .NET 5. We have also added new test cases, which I'll be discussing in depth much later in this session. These new test cases cover MSFSA, MSFSCC, and MSSMB2 protocols. We also worked on some bug fixes for this release. Regarding the Protocol Test Manager, the Protocol Test Manager command line interface, PTM CLI, has been migrated to .NET 5, and the PTM test logger has been removed from the PTM CLI. This release also includes some bug fixes. Note that for proper operation of the PTM CLI tool, you will need to generate a PTM profile from the UI. Please refer to the PTM CLI guide for syntax and general usage guidelines. For this release, we've added new test cases, some of which include tests to check if colon and backslash are contained in a file name, and we included tests covering both files and directories. We've also included tests to check file creation, access, and write times, file modification algorithm, among others. There are also now tests to check Oplock key comparison algorithms and new tests to check if AES-256 CCM and AES-256 GCM encryption is supported. For the AES-256 encryption tests, this is a new feature available right now on Windows 21 H1. You can find a detailed description of this feature in the latest MS-SMB2 document. This document is on the Microsoft OpenSpecs documentation site, and the link to this is on the screen. We have new tests that cover both negotiation and encryption scenarios. Please note that these tests did not make it into release version 4.21.5.0, but they are available on the Windows Protocol Test Suite's GitHub repository as of today. So to run these tests, you will need to build from the repository to run these tests for now. Let's take a look at an AES-256 negotiation test to get a feel for the test cases. The test we'll discuss is the negotiate test, the BVT negotiate SMB 311 pre-authentication encryption AES-256 CCM test. This test requires a setup with a test driver and an SUT. The first step is to establish a connection from the test driver to the SUT. Step 2 involves sending a negotiate request packet to the SUT with the protocol set to SMB 3.11 and the encryption capability set to AES-256 CCM. We expect the SUT to send back a negotiate response with protocol set to SMB 3.11 and the encryption capability set to AES-256 CCM. This indicates that the SUT supports AES-256 encryption, CCM encryption protocols. A set of new test cases that are available in the current 4.21.5.0 release are the tests for Oplock Lease keys. For more information on the Oplock key algorithms, check out the Microsoft OpenSpecs documentation available at the shared link. There are 7 new test cases for this scenario that span tests for both files and directories. Also worth noting is that this is supported on SMB 2.1 and greater. Using the comparing same lease keys v2 test, let's take a closer look at a sample Oplock keys test. The setup here also requires a test driver and an SUT. The first step here is to establish a connection with the file server. Next, the test driver creates a file on the SUT with a lease, which we call lease open. The test driver then attempts to open a new connection to the same file with the same lease key. We refer to this second connection as operation open. We then perform several verifications on the state of these two leases. Firstly, we verify that a lease break notification is not received after operation open. Then we verify that lease opens lease key is the same as operation opens lease key. And finally, we verify that lease opens parent lease key is the same as operation opens parent lease key. Successful completion of these verifications is an assurance that the algorithm is correctly implemented. Let's move over to a demonstration for running these tests. In this demo session, we are going to execute some of the new test cases using the Protocol Test Manager. On the screen, we have a Windows VM to which we have installed the latest version of the Protocol Test Manager downloaded from GitHub. And we have also copied and extracted the latest FileServer Test Suite version. You can see the zipped FileServer Test Suite file and the unzipped folder. To run the new tests, we start up the Protocol Test Manager. We get a nice GUI and we can see the option to select the test suite you intend to launch. we want to launch the FileServer test suite. So we click on select. This enables us to select the folder where the FileServer test suite is extracted into. This is on the desktop. It will automatically detect the FileServer test suite version number, which you can see is 4.21.5.0. We click on the configuration wizard to proceed. This screen provides some introduction to the test suite and includes a helpful link to a deployment guide, which is very helpful to describe how the test environment should be set up. We click on next. This asks us to choose our preferred configuration method. Here we are going to use run auto detection, which will automatically retrieve the capabilities of the SUT. We have a warning that this auto detection may create directories or files on the SUT. We want to continue. We enter the values for our SUT. In this case, the SUT is VM S32. We also replace this value here. We have created a directory, a shared directory called SMB Basic on the SUT. And we also change the administrator password. We switch the authentication to NTLM and click detect. After detection completes, you click next and you can view the detection results and the capabilities of the SUT. There are a huge number of possible test categories, but we want to filter down, and this allows us to filter. So what we are going to do is filter only positive non-BVT cases, only SMB 3.1 cases, and this already filters down to a more manageable number. So the test cases we are interested in running are available here. Click next. Here we could set additional configuration properties. The highlighted properties here are different from the defaults, and this helps call your attention to any value that could be incorrectly configured. We click on next. There's the option to configure the adapters used to run the test cases. We will leave them on the default values. Here we select the actual test cases that we want to run. There's the option to run all test cases or run just a selected few. The test cases we want to run are some of the new Oplock Lease keys test cases. We have the comparing same lease key v2 test case, and we have the directory comparing lease keys v2 test case. Click run selected cases. We'll wait for a few moments for the test cases to run. When the test completes, we can view the results up here. Clicking on each test result shows you more details about the test. Thanks for watching.